the 2023 Nobel Prize season has just come to an end. Today at Synapse, we celebrate mind-boggling achievements and the people who pioneered them, pushing the horizons of scientific inquiry like never before. A life-saving work that helped fight the deadly pandemic, this year's Nobel Prize in Physiology or Medicine was awarded to Katalin, Karikó and Weissman. Their pioneering work on mRNA fast-tracked the first-ever, and highly effective, vaccines against the COVID-19 virus. Karikó and Weissman began harnessing the potential of the mighty mRNA in the 1980s, when the mRNA first began to be synthesized outside the body and in the lab. They realized that lab-developed mRNA molecules were seen by human cells as foreign objects triggering inflammatory responses. They devised an elegant solution by directly modifying nucleosides, the molecular letters that write the mRNA's genetic code. Their collaboration created history and marked a pivotal moment for mRNA-based therapeutics. The modified mRNA could now cruise comfortably under the immune system's radar, while also generating more viral proteins. A win-win that meant mRNA could now be used clinically. Cut to 2020. Karikó and Weissman's work provided the basis on which mRNA vaccines were developed and deployed in humans during the COVID-19 pandemic. With a 95% efficacy rate. Vaccines against the next unknown pandemic and known infectious diseases, therapeutic protein delivery. Targeted cancer treatment. The potential and possibilities of harnessing mRNA can revolutionize healthcare. Next up is the 2023 Nobel Prize in Physics. It was awarded to Pierre Agostini, Ferenc Krausz, and Louis for their pioneering experiments that will help observe and understand the rapid activity of electrons, literally in a new light. Just like a high shutter speed camera catching the movements of fast-paced objects in motion, attosecond pulses of light help catch the ultra-fast movements of electrons. To put into perspective, a second contains as many attoseconds as there have been seconds since the birth of the universe. Capturing events in attoseconds will unravel the nature of electrons in unimaginable ways. Back in the 1980s, Louis discovered that shining an infrared laser light through a gas incited interactions within the atoms that ended up creating excess energy and light. As Louis continued with her experiments, this new understanding pushed more scientists to delve deeper. By 2001, Pierre Agostini figured out how to create and observe a series of light pulses, one after the other. Each pulse lasted just 250 attoseconds. Around the same time, Ferenc Krausz found a way to create a single light pulse that lasted 650 attoseconds. These extremely short-spanned light pulses helped provide imaging of how an electron behaves, giving us the ability to make sense of their rapid movements. And harness them better. Think improved disease detection by catching molecular-level changes in blood. Think improved electronics by better utilizing the properties of electrons. The possibilities unleashed by attosecond physics have sprung us into the future, in the blink of an eye. The last Nobel Prize in the sciences is dedicated to the field of chemistry. This year, Moungi G, Bawendi, Louis E. Brus, and Alexei I, Ekimov were awarded for their discovery in synthesis of quantum dots. An element, whether 1 kilogram or 100 grams, has the same properties and behaves the same way, thanks to the number and distribution of electrons in an element. But when we shrink substances down to incredibly tiny sizes, this fundamental concept no longer holds true. In the nanoscale range, as electrons become packed in tighter and tighter, they begin to behave differently. Quantum effects, those that rule the world of subatomic particles, begin to come into play. Size now determines the properties of the particle in question. Ekimov and Brus were the first to notice, and recreate, this odd behavior over 30 years ago. Bawendi developed easier ways to produce nanoparticles that would show desired, deviant behavior. These nanoparticles with special properties, or quantum dots, teetering on the edge of classical and quantum, have already become an integral part of our lives. They exhibit fascinating and unusual properties, such as changing colors depending on their size. We use them in LED lamps, television screens, live imaging and medical diagnosis, and solar cells. As the field of nanotechnology scales ever higher heights, the use of quantum dots will continue to become more important than ever. Be it the ability to create life-saving drugs or uncovering new mechanisms that change the course of time, these Nobel laureates have made significant contributions to our understanding and applications of scientific phenomena, work that has shaped and continues to shape our life. For more developments on Science Tech Society, keep watching Synapse.